Hello students, welcome to the first lecture on the lecture series on work and time. Okay, so in this lecture what we'll be doing is we'll be covering all the basic concepts and we'll be covering some types of problems that are being asked on work and time in various competitive exams. Okay, so let's proceed with this lecture. So in this lecture we'll be covering the concepts, okay, and the types of problems on work and time. Okay, so what kind of problems are being asked in the exam on this topic. So let's go forward. So what we'll be doing is we'll be giving a brief introduction on the following topics. That is, what is work formula? Okay, what is work? We'll discuss. Then we'll discuss what is work formula. We will also discuss what is inverse proportion, what is direct proportion. Okay, how they are different. Okay, and how they are useful in work and time. Okay, so what is their concepts, and we'll see what efficiency is and how it affects work and time, and we'll also see combined work. Okay, so work formula is nothing but the relation between amount of work done in specific time. Okay, so inverse proportion is relation between work and time. Okay, how they are involved, and direct proportion is a specific kind of relation between two elements in work and time. Okay, so we'll see it in detail. So, and efficiency is how much can you do in specific amount of work without wasting any time. Okay, so taking breaks or taking naps or taking more time than you should, that is, let's say you are given 3 balls. Okay, so what we are told to you is, it was told to you that you throw them 100 meters. Okay, all the 3 balls, not at once but one by one. So what you do is you throw one ball, then you take rest. Okay, then you throw again one ball, then you take rest, let's say for 1 minute, and then you throw another ball. Okay, so you threw how many balls? 3 balls in 2 minutes. Okay, because you took 2 rest times, that is of 1 minute each. Okay, but you had potential to throw 3 of these balls without taking any rest. So your efficiency gets decreased here because you took more time than it is normal. Okay, so normally you shouldn't have took more time or rest time. Okay, so this is where efficiency comes into place. So there will come another boy who will throw 2 balls 100 meter, then he will take 1 minute rest. Okay, so his efficiency is better than yours. Okay, so this is what efficiency is. We'll see what exactly is efficiency in detail. Okay, so we'll see also combined work. If 2 people are there and they have different efficiency, then how much time will they take? Okay, if we are given individual times, then how much will they take combined? Okay, so these kind of concepts we will learn in this topic. Okay, what is work formula, what is inverse proportion, what is direct proportion, what is efficiency, what is combined work. So let's see what work formula is. So the basic formula for the time and work problem is work done is equal to what? Rate of work into time taken. Okay, so this is the formula that you need to remember or get master at. So this formula will be used very often in this chapter. Okay, so please remember this. So time taken for a work is equal to what? 1 by rate of work. Okay, so this is the second formula. So this is the first formula, this is the second formula. And what is called rate of work? So rate of work is nothing but 1 by total time taken to finish that work. Okay, so work done is equal to rate of work into time taken. Okay, and what is time taken for a work is equal to 1 by rate of work. Okay, and what is rate of work? Rate of work is nothing but 1 by total time. Okay, so let's go forward. So the second concept was inverse proportion. So the more people there are, the less time it takes to finish that job. Okay, let's say you have a job to dig a hole in the ground. Okay, hole. Initially what you had was you had 2 people, 2 diggers. Okay, but you realize that you need more people in order to dig it faster. So you gave 2 more people. Okay, so we added. So there are 4 people. Now the hole is digged at half the time. Okay, because the number of people increased. So number of worker increase imply number of or amount of time decreases, right? So this is the relation that is called inverse proportion. So the more people there are, the less time it takes to finish that job. Thus, there is an inverse correlation between the number of workers and the duration required. Okay. So the ratio at which the number of worker will increase, that is the same ratio at which the amount of time will decrease. Okay. So this is the relation, that is the inverse proportion relation. So number of workers is directly proportional to 1 by time, or we can also say that number of workers is inversely proportional to time taken, okay, by those workers to complete that specific work. So this is important relation. Okay. So let's see what is direct proportion. So the relationship between the number of workers and the amount of work done is directly proportional. Okay. So the relationship between the number of workers and the amount of work done is directly proportional. So more workers generally lead to more work completed in the same amount of time. Okay. So the number of workers is directly proportional to amount of work done. Okay. So this is the second important fact or statement or correlation or relation. Okay. So let's see what is efficiency means. Okay. So efficiency is a measure of effectiveness. It's a measure of effectiveness. Okay. Of a worker or a machine in completing a task. Okay. So how effectively he completes a task. Okay. So efficiency is equal to amount of work done by time taken. In other words, okay, so this formula is important. So please remember this one too, right? So in other words, efficiency is the ratio of work done by worker or machine to the time taken. So it is often expressed as percentage. Okay. So efficiency is equal to work done by time taken into 100, as we want to tell it in percentage. Let's say you have a man. So you have Anuj. Okay. And what you asked Anuj to do is you asked Anuj to dig a 8 feet hole. And he took approximately 4 days to complete it. Okay. So 8 by, let's say it is what, 2 feet hole. Okay. So 2 by 4 into 100. Okay. So this is nothing but 1 by 2 into 100. This is equal to 50. So the efficiency becomes 50%. Okay. So let's see the fifth concept, that is combined work. So when multiple workers or machines work together, okay, when multiple worker or multiple machines. So multiple is the keyword here, because without multiple it will become very basic work and time problem, not a combined work problem. So in order to see for combined work, what you need is you need two different perspective people or different type of people whose efficiency is different, whose category is either different, or their task is either different. Okay. So multiple workers or machines are really necessary to call it a combined work problem. So work together to complete a task. The combined rate of work can be calculated as the sum of individual rates. Okay. So let's see how. So if A and B can complete a task in X and Y days, okay, respectively, then their combined work rate per day when working together is given by 1 by X plus 1 by Y. Okay. So combined rate is equal to rate of work by A plus rate of work by B. Okay. So rate of work by A is equal to 1 by X and rate of work by B is equal to 1 by Y. Rate of work of A, rate of work of B. So let's see the types of questions. So there are actually 8 types of questions that are basically asked on work and time. So the first case is individual work rate. The second one is on combined work rate, that is two different kind of people are there and or two different kind of tasks are there. Okay, that kind of question is called combined work rate. And third question is about work efficiency. Okay, how efficient is Anuj than Anup, or how efficient is Aditya than Ravindra. Okay, so in the fourth kind of question, fraction of work done. Okay, so if Anuj can dig a hole in 3 days. Okay, how much can he dig in 1 day? Right? So this is a question that represents fraction of work done. So the fifth kind of question is shifting work. Okay, what is shifting work? And sixth kind of is reciprocal work rates. 7 is on work allocation and 8 is on work reduction. Okay, we will see each one in detail. So let's go forward with it. So individual work rate. So finding the time taken by an individual to complete a task working at a given rate. Okay, so the time taken by an individual to complete a task working at a given rate. Let's see an example. So A can complete a job in 10 days. So find the work rate of A. Okay, so what does A do? A completes a job in 10 days. Okay, so we want to calculate the work rate. So what is the formula? So work is equal to rate into time. Okay, so work is equal to one job, as the entire job is completed, time is 10 days. So rate is equal to work by time, that is 1 by 10, that is 0.1 job per day. So if we are given a question that A can complete a job in 10 days, find the work rate of A. So work rate of A is 0.1 job per day. So let's see question number 2. So combined work rate. So calculating the time taken when two or more individuals work together to complete a task. So calculating the time taken when two or more individuals work to complete a task is A and B can complete a job in 6 days and 10 days respectively. So find the time taken when they work together. Okay, so given that A and B can complete a job actually in 6 days and 10 days. Okay, A can complete in 6 days and B can complete in 10 days. Find the time taken when they work together. So step 1 tells us that calculating combined work rate. So combined work rate will be 1 whole by 1 by 6 plus 1 by 10, that is equal to 30 by 8. Okay, so 3.75 jobs per day is the correct answer. Okay, so find 2. What we do in step 2 is we find the time taken. So work by rate is equal to time. So 1 by 375 is equal to 0.267 days. So 6 hours and 24 minutes is what they to take to complete the task. So let's see the third kind of question, that is on work efficiency. Okay, so comparing the efficiency of different individuals or machines in completing a task. So let's see a problem on this to get a better gist at it. So A completes a job in 8 days, okay, with 80% efficiency. So find the time taken by B to complete the same job with 60% efficiency. Okay, so given that we have a person A who completes the job in 8 days with 80% efficiency. So find the taken by B to complete the same job with 60% efficiency. So in step 1, what we do is we calculate the work done by A. So work done by A is equal to what? 80% of the job, that is equal to 0.8 job per day. So find the work done by B is equal to work done by B is equal to total job minus work done by A is equal to 0.2 job. So time taken by B is equal to work done by B by efficiency of B is equal to 0.2 into job. 0.2 job by 60% is equal to 0.2 job by 0.6 is equal to 1 by 3, nothing but 1 by 3, that is 0.333 days, that is equal to 8 hours. Okay, so 8 hours is the correct answer. So types of questions. So 4, fraction of work done. So determining the portion of work completed by an individual or group in a given time. Okay, so determining the portion of work completed by an individual or group in given time. So if A completes 1 by 3 of a job in 6 days, and find the total time taken to complete the entire job. Okay. So what we do first is we find the work done by A in 1 day. So for how much work does A do in 1 day? So work done in 1 day is equal to 1 by 3 of job, whole by 6 days, that is equal to 1 by 18 job per day. So step 2 is calculating the total time. So calculating is the total time is very easy, that is total work by work done in 1 day. So one job by 1 by 18 is equal to 18 days. Okay. So let's see the type of question, that is shifting work. So finding the time taken to complete a task when workers or machine work in shifts. Okay. So basically when anyone works in shifts, there comes the concept of shifting work. So let's see problem. So A and B work together for 5 days and then B and C work together for 3 days. So find the total time taken to complete the job. We want to find the total time taken to complete the job. So calculate A, B combined work rate. Combined work rate of A and B is equal to 1 by 5 days is equal to 0.2. So calculate B and C combined work rate. So combined work rate of B and C is 1 by 3 days. Total work is equal to combined rate of A and B plus combined rate of B and C, right? Into 8 days. So 1 by 5 plus 1 by 3 into 8. Because in 1 day they finish this much, they finish this much. So 8 by 15 is into 8 is equal to what? 64 by 15 jobs. So let's see step number 4. So finding the total time. So total time is equal to what? Total work done by combined rate of A, B and C. So 64 by 15 by 1 by 5 plus 1 by 3 is equal to 8. So 8 is the correct answer. Let's see the sixth kind of question. So reciprocal work rate. So using the concept of reciprocal work rates to solve complex time and work problems, A and B can complete the job in 12 and 15 days. So respectively, how much the job is completed by A in the time taken by B to complete the entire job. Let's see. So find the work rate of A and B. So 1 by 12, 1 by 15. Calculating the total work done by A in time taken by B is equal to work done by A is equal to rate of A into time taken by A. So what is it equal to? Rate of A into time taken by B. So 1 by 12 into 15, 5 by 4 job. So let's see the seventh kind of question, that is on work allocation. Allocating work to different individuals or group based on their work rates. So A, B and C can complete a job in 4, 6 and 8 days respectively. So how much work should we allocate to each person to complete the job in 2 days? So calculate their combined work rate, that is 1 by 4 plus 1 by 6 plus 1 by 8, that is equal to 24 by 6 plus 4 plus 2. So this is 13 plus, so 24 by 13 is the correct answer. 24 by 13 jobs per day. So find the total work done in 2 days. So total work is equal to combined rate into time. 24 by 13 into 2 is equal to 48 by 13. Okay, so this is the correct answer. So allocate work to each person. So allocated work to A is equal to rate of A into time is equal to 1 by 4 into 2 is equal to 1 by 2 of job. So work allotted to B is equal to 1 by 6 into 2, that is equal to 1 by 3 job. Work allotted to C is equal to rate of C into time is equal to 1 by 8 into 2 is equal to 1 by 4 job. Okay, 1 by 4 job per day. Work reduction. So calculating the reduced time to complete a task when more workers are added. So if AB can complete a job in 12 and 20 days respectively, if C is added to the team, how much will the time reduce to complete the job? So calculating their combined work rate. So combined work rate of A and B is equal to 1 by 12 plus 1 by 20. Okay. So 1 by 5 by 60 plus 3 by 60 is equal to 60 by 8 is equal to 7.5 jobs. So finding the reduced time is equal to what? Total work done by combined rate of ABC, that is equal to 1 by 7.5 is equal to 0.1333 days. So that is approximately equal to 3 hours and 12 minutes. So we have learned till now what is work formula. Okay. What is work formula? What is inverse proportion? What is direct proportion? How they are related? So we have learned efficiency. We have learned combined work. So let's revise all the important formulas. That is work done is equal to rate of work into time taken. Time taken for a work is equal to 1 by rate of work. The rate of work is equal to 1 by time. So we learned what was inverse proportion. Okay, if one thing gets increased by specific ratio, the other thing decreases with that specific ratio. Okay, here in the first case it increased, in the second case it decreased. That is what we called as inverse proportion. If one gets larger, the other one gets smaller. Okay, in order to fill the equivalent. So direct proportion is equal to what? So the relationship between numbers of workers and amount of work done is directly proportional. So more workers generally lead to more work completed in the same amount of time. So the number of workers is directly proportional to number of workers. So what is efficiency? Efficiency is a measure of effectiveness. Okay, that is what efficiency is. So it is a measure of effectiveness of a worker or a machine in completing a task. So in other words, efficiency is equal to amount of work done by time taken. So efficiency is the ratio of work done by the worker or machine to the time taken. So it is often expressed as percentage, in percentage. Okay. So efficiency in percentage is equal to what? Work done by time taken into 100. We also saw what is combined work. So when multiple workers on machine work together to complete a task, the combined rate of work can be calculated as a sum of individual rates. So combined work, if A and B can be complete in a task in X and Y days, so respectively, then their combined work rate per day when working together is given by what? 1 by X plus 1 by Y. So let's see the type of questions. So there are 8 type of questions that can be made on work and time. That is individual work rate, combined work rate, efficiency, work efficiency, fraction of work done, okay, shifting of work, reciprocal work rates, work allocation, work reduction. So all these type of questions are being asked on various competitive exams. So it is very important to you to go through all these type of questions. So let's go through them. So individual work rate is nothing but if A can complete a job in 10 days, find the work done of or work rate of A. This was an example. So if A can complete the job in 10 days, the work rate of A is equal to what? We use work is equal to rate into time. So substitute the given values, that is work is equal to 1 job, time is equal to 10 days. So solve for the rates. So rate is equal to what? Work by time is equal to 1 by 10 is equal to 0.1 job per day. So combined work rate, so calculating the time taken to compute 2 or more individuals work together to complete a task. So if A and B can complete a job in 6 days and 10 days respectively, then find the time taken when they work together. Okay, when they work together, what is the time taken by them is 3.75. What you do is find the time taken, that is time is equal to work by rate is equal to 1 by 375. 3.75 whole is equal to or approximately is equal to 0.267, and that is approximately equal to 6 hours and 24 minutes. So work efficiency, comparing the efficiency of different individuals or machines in completing a task. So completeness, A completes a job in 8 days. Okay, we solve it. It is 0.2 job. So find the time taken by B is equal to 8 hours. So fraction of work done. So determine whether the portion of work completed by an individual or group in a given time. If A completes 1 by 3rd of a job in 6 days, so find the total time taken to complete the entire job. Okay, so it will take 18 days. So step 1, the work done by A in 1 day is 1 by 3 whole by 6 is equal to 1 by 18 per day. So calculate the total time, that is total time is equal to total work by work done in 1 day. So 1 job by 1 by 18 is equal to 18 days. So shifting of work. Okay, let's see an example. If A and B work together for 5 days and B and C work together for next 3 days, find the total time taken to complete the job. So total time taken will be 1 by 5 is equal to what? This much amount of job per day. So calculate B and C combined work rate. Combined rate of B and C is equal to 1 by 3 days. So 1 by 3 jobs per day. So calculate the total work done in 8 days. So 1 by 5 plus 1 by 3 into 8. So this is equal to 8 by 15 into 8 is equal to 64 by 15. So total time is equal to what? Total work by combined rate of A, B and C. So 64 by 15 whole by 1 by 5 plus 1 by 3. This is equal to 8 days. So let's see what is reciprocal work rates. Okay. So see an example. A and B can complete a job within 12 and 15 days respectively. So how much the job is completed by A in the entire time taken by B to complete the entire job? So find the work rate of A and B. It is 1 by 12 and 1 by 15 respectively. So calculating the work done by A. In the meanwhile, work done of A is equal to rate of A into time taken by A. B, that is equal to 1 by 12 into 15 is equal to 5 by 4. So work allocation, allocating work to different individuals or group based on their work rates. Okay, let's see an example. So if A, B, C can complete a job in 8, 6 and 4 days respectively, how much work should be allocated to each person to complete the job in 2 days? So calculating their combined work rate is what? 24 by 13. So this much amount of jobs per day. So find the total work to be done in 2 days. Total work is equal to combined work into time. So 24 by 13 into 2 is equal to 48 by 13. So 1 by 4 into 2 is what? Work allocated to A, that is equal to half of the job. So work allocated to B is 1 by 3 of that job. So work allocated to C is 1 by 4 of that job. So let's see the 8th kind of question, that is on work reduction. So calculating the reduced time to complete a task when more workers are needed. So if A, B, C completed a job in 12 and 20 days respectively, if C added to the team, how much will it time that reduced to complete that job? So step 1 is calculate their combined work rate. Then combined work rate of A and B is equal to what? 1 by 1 by 12 plus 1 by 1 by 20. So this is equal to 60 by 8. So 7.5 jobs per day. Okay. So that's all for now. Thank you.